Hi everyone, in this lesson we look at how to find the vertex of a quadratic formula. So in this first example it says determine the value of c such that the following are perfect square trinomials. Now I know that this seems like it's an exercise in factoring, but it's going to be useful when we go and we work through completing the square. So first we have x squared plus 4x plus c. And let's think about what value we need for c in order to get a perfect square. So if I think about this and I expand, let's say, I don't know, like x plus 1 squared, then I get x squared plus 2x plus 1. If I expand x plus 3 squared, well, that's equal to x squared plus 6x plus 9. So let's do one more. Let's do, I don't know, x minus 4. 4 is a bad example. Let's do x minus 5 squared. So for x minus 5 squared, you'd get x squared minus 10x plus 25. Now notice something here. For all of these values, how do the value of c and the value for c, which is this value here, and the value of the coefficient on the linear term relate? Well, notice that in all three cases, if I take half of the coefficient on the linear term and then square it, I get c. So to find c, all that I need to do is take half of whatever this coefficient is and square it, and I'll get c. Like for instance, 9 is half of 6 squared. 25 is half of negative 10 squared. So let's go ahead and use that. So c here, well, this would be equal to, c would have to be equal to, let's do 4 over 2 squared. Because I'm literally just going to take half of whatever this coefficient on x is and square it. So if I do 4 divided by 2, I get 2. 2 squared is 4. In this example, c is equal to, well, c would have to be half of 3 squared. So if I take 3 and divide it by 2 and then square it, that's equal to 9 over 4. Now let's go ahead and use this this method in some algebra. In the second example, we're told to find the vertex of each function by completing the square, and is the vertex a maximum or a minimum? So basically our objective here is to rewrite each of these functions in the form f of x is equal to a times x minus h squared plus k. So let's start out with a. So first off, I'm going to try to make this x squared plus 3x a perfect square. So in order to make it a perfect square, I have to, I would have x squared plus 3x, and then I'm going to add 3 over 2 squared. So all that I'm doing is I'm taking 3 over 2 and I'm squaring it. So I'm going to add 3 over 2 squared, which is 9 over 4. I can't just add 9 over 4 to this expression because that changes the value of this expression. So I'm going to add 9 over 4 and then I'm going to subtract 9 over 4. So I've essentially just added 0. Now, x squared minus 3x plus 9 over 4 is a perfect square trinomial. That's because if you take the a coefficient or if you take the square root of the a coefficient and you multiply it by the square root of 9 over 4 and then double it, you should get 3. So that's how you figure out whether it's a perfect square trinomial. And in this case, it is a perfect square trinomial because we've set it up that way. So x squared plus 3x plus 9 over 4 factors to x plus 3 over 2 squared. And then outside the bracket, I have negative 9 over 4 plus 5. And I can combine these constants to minus 9 over 4 plus, if I want to find a common denominator, I could write this as 20 over 4. So this is equal to x squared plus, x squared plus 3 over 2, x plus 3 over 2 squared plus 11 over 4. Plus 11 over 4. Okay, so the vertex of this function, of this first function, the vertex is negative 3 over 2 comma 11 over 4. Now the question doesn't just ask where the what the vertex is. It also asks, is the vertex a maximum or a minimum? So recall that this a coefficient here, if this a coefficient is if this a coefficient is positive, that means that this parabola opens upward. So this would look something like, well, I could try kind of sketch this out. The vertex is at negative 3 over 2 comma 11 over 4. Negative 3 over 2 comma 11 over 4. Let's just say it's here. And it opens upward. So that means that we have a minimum. So the vertex is a minimum. And that's because the parabola opens upward. So in example B, we have a fraction. And we have a coefficient that's not equal to 1. So B is a little bit different than A. In A, we had a coefficient of 1 beside x squared. So the first step in completing the squared is to factor out this a coefficient between the quadratic term and the linear term. So this is your quadratic term, this is your linear term. I'm going to common factor negative 2 over 3 out of both of those terms. So and I'm going to leave the constant term outside of the brackets. So I'm going to have negative 2 over 3 x squared. And now I've got to divide 4 by negative 2 over 3. So how do I do that? Well, 4 divided by negative 2 over 3. Remember that division is the same thing as multiplication by the reciprocal. So 4 divided by negative 2 over 3 is the same thing as 4 times negative 3 over 2. Well, 4 times negative 3 over 2 is equal to minus 6. Because 4 divided by 2 is 2. 2 times negative 3 is negative 6. So I get negative 2 over 3 times x squared minus 6x bracket plus 1. Now, important thing, the constant stays outside of the bracket when I'm completing the square. So the next step is to figure out, well, look at this, the form that this equation is written in. And this is the form that I'm trying to put this in. So I need to try to get a perfect square trinomial inside of these brackets here. So again, the way to do that is to figure out what half of negative 6 is, square that, and then add it and subtract it. So half of negative 6 is just negative 6 over 2. And if I square that, I get that this is equal to 9, because negative 6 divided by 2 is negative 3. Negative 3 squared is equal to 9. So I'm going to do negative 2 over 3 times bracket x squared minus 6x plus 9. Now remember, I can't just add 9 because that changes the value of my expression. So I'm going to subtract it as well. And I'll leave this constant outside of the brackets. So the next thing to notice is that inside of these brackets here, inside of this bracket, these round brackets, or parentheses, or whatever you want to call them, I have a perfect square trinomial. So that factors to x minus 3 squared minus 9 plus 1. Now, the last thing I need to do to make this equation look like this equation is just to distribute negative 2 over 3 into the bracket. So I'm just going to distribute negative 2 over 3 into this term and into this term to get rid of the square brackets. So if I distribute negative 2/3 to x minus 3 squared, I get minus 2 over 3 times x minus 3 squared. If I distribute negative 2/3 to minus 9, well, let's see here. 3 times, or sorry, a third times negative times a third times 9 is just 3. So I've got negative 2 times 3, which is positive 6. And I get positive 6 because I'm multiplying a negative and a negative, which gives me a positive. So I've got positive 6 plus 1. Combining the two constants, I get negative 2 over 3 times x minus 3 squared plus 7. And so in this example, we have to determine whether the vertex is a maximum or minimum. First off, our vertex is 3, 7. And we have to figure out whether this is a maximum or a minimum. So this parabola is concave. It would be concave down. So it's going to look something like this. And I'm sketching it without considering where the zeros are. So this is going to have a maximum. So the vertex is a maximum. And that's because a is less than 0. And here again, we could have said that a is greater than 0, so the vertex is a minimum. That concludes this video, and we'll see you in the next lesson.